We'll start at 3.
Yes.
Okay. So number A, find the limit as x approaches 2 from the right and the limit as f approaches 2 from the left. From the right, what is it?
It looks like it's a 2.
Correct. From the left, what is it?
From the left, it's 1.
Okay, number B. Does the limit of f of x exist as x approaches 2?
No, because the left and right hand limits do not match.
Okay, C. Find the limit of f of x as x approaches 4 from the left. No, from the left.
It would be 3.
Good. About from the right?
3.
So what's the limit as it approaches 4?
3.
Correct. Notice that on none of these do we have to look at the piecewise function. It's not even a factor. We're doing all of these questions based on looking at that graph, right?
Yes.
Much easier to do limits when you're looking at graphs than if you were trying to figure it out from just the piecewise function. All right. So number 4. Hold on a minute. No, I guess, well, I can kind of see it. Is this on the second page, perhaps? The rest of 4?
Possibly. I think I emailed you another one, actually, for the continuation.
Okay. All right. Again, I don't even care about this piecewise function over here. I'm going to base everything on my graph. What's the limit as x approaches 2 from the right?
It is 1.
From the left?
1, making it 1.
And what is f of 2?
That would be 1.
No?
No. It would be 2 because the 1 is a whole.
Correct. And this is a excellent example of where your limit can be actually different than what the function is evaluated at that number. In other words, the limit was 1, but the function is actually 2 at that point. But that's the only point that it's 2. All right, B.
So
Does
that
the
would
limit exist?
Yes, because the left and right hand limits are 1.
Correct. About as we approach -1 from the left?
That would be 4.
From the right?
4 as well.
So does it exist?
Yes, it would be 4.
Okay. All right, the next one. This is a more interesting function. Notice that they cannot even draw the function because it oscillates so frequently, its period approaches 0. If you look at this function here, it oscillates, but it starts oscillating really quickly. So quickly that it makes a difference mathematically. So does the limit as x approaches 0 from the right exist?
Yes. Or no, because it's oscillating.
Well, in this particular case, it's well worth looking at the function. In other words, we can't really, you're right, it does not exist because it's oscillating. But we can't really tell that from the graph because the graph doesn't even go over to 0. It stops right there. Okay, so if we are approaching from the right, we're using this bottom function, correct?
Yes.
And if you plug in 0 for x, you get the sine of 1 over 0. That's problematic, especially since the sine fluctuates between -1 and 1. So I have no idea what the sine of infinity or negative infinity is. And that's what you get when you divide by 0. So you can really see the fact that it's not going to exist more from the algebraic equation or the piecewise function than the graph. It's hard to see it from the graph. How about the limit from the left?
That would be 0.
Good. So does the limit exist as x goes to 0?
No, because left and right hand limits do not match.
Right. In fact, one doesn't exist and the other is actually equal to a number. So let's see, I need to go back a page to get back to 6. I think so. Let me do it this way. That is an interesting function. Trying to figure out what it is exactly that is the function. It's the blue? What's the yellow and the red? The red is y equals square root of x. The yellow is y equal negative square root of x. And the blue is square root of x times sine of 1 over x. Okay. Does the limit from the right exist?
Yes.
It looks to me to be oscillating again.
Yeah, I guess so.
If you plug in 0 from the right, you're going to get 1 divided by 0. So that produces this oscillation here that just gets quicker and quicker and quicker the closer you get to 0. So you can't really say that there's a limit. It's not approaching a constant value. So the answer to A would be no. How about B? Does the limit exist as we approach from the left?
No, because there isn't a line.
Yeah, the function does not exist to the left of the y-axis. So yes, you're correct. No is the answer. For C,
Yeah, it would be does not exist.
Sure looks like it should be 0, huh?
Uh-huh. Kind of, but not.
Do you have answers on these?
Unfortunately not.
Okay.
Only on odds.
Because this looks kind of special. I'm not quite sure why this problem is on the review, but it might be different than number 5, which was a similar oscillating function. I guess we don't really care what the red and the yellow look like. The blue is the product of the two. So the blue is the function that they're talking about. And we can see from the blue that it's oscillating and oscillates more and more as we approach 0. So,
Okay.
oops. Number 7. Do you know what the graph of x cubed looks like?
Yes, it's like a line from the top right goes to the origin and goes down to the left.
Yeah, let me just draw it real quick here. So that's y equals x cubed. But this is a piecewise function. It's only equal to x cubed when x is not equal to 1. When x is equal to 1, it's equal to 0. So if we put 1 on there, then we have that and we have a hole right there. Does that look right in terms of graphing it?
Yes.
Okay. So find the limit. Yeah, unfortunately now I can't hear. Let me blow that up a little bit. So find the limits as we approach 1 from the left and the right. First of all, what is this value right here?
1.
Yeah, that's 1 also. So what's the limit as we approach 1 on the x-axis from the right?
1.
And from the left?
1.
Therefore, its limit?
1.
Okay. This is a very similar problem to number 4, where the limit was not the same as the value of the function at that point. And that's pretty much the same here. The limit's 1 from the left and the right, but the function is 0 at 1. In other words, f of 0 is, or excuse me, f of 1 is 0. Okay, so now they're getting into questions where they don't give you a graph. And so you have to kind of do it from the algebraic representation of the function.
Okay.
So if we try to do 8 and we try to do it without drawing it,
That'd be difficult.
let's try it. It's equal to 1 minus x squared everywhere except at 1, where it's equal to 2. So which function is going to rule here? Top one or the bottom one? In terms of limits.
The top one?
Yeah. So what's the limit of the function as we approach 1 from the right?
That would be 1.
Substitute 1 for x.
So that would be 0 then.
Okay, how about from the left?
That would just be 2.
No, that'd be 0 also.
Oh, you plug it in. Okay, never mind.
Okay. If I were to graph this, that's just a parabola that points down and it's been shifted 1 unit up.
Okay.
Okay, except the only difference is at x equal 1, it's got a point that's 2. It's also much like 4, where the limit of the function is going to point to 0 from the left or the right, but at 1 itself, it's equal to 2. So this limit does exist and is equal to 0. And as long as we're talking about this, let me tell you the official definition of continuity. The layman's definition of continuity is if I can draw the graph without lifting my pen. That graph I just drew is continuous. If I draw this graph, I have to lift my pen up to do it.
True.
Okay? But the mathematical definition of continuity, let's say, are we continuous at x equal 3? And 3 things have to be true for us to be continuous at x equal 3. We have to have the limit as we approach 3 from the left equals f of x, whatever that is. We have to have the limit as we approach 3 from the right equal f of x, whatever that is. And we have to have f of 3 equals f of x. In other words, if all 3 of these are true, then the function is continuous. And continuity is big in calculus because continuity is what determines whether you can differentiate something at that point. Okay, now if we look at some of these functions, certainly 3 is not continuous, right?
Yes.
Because the limit from the right is not the same as the limit from the left, so that's why that's not continuous. 4 is not continuous. The limit from the left is the same as the limit from the right, so the limit exists, but the value of the function is not equal to the limit at that point. So 4 is not continuous.
Okay.
Okay, so there's 3 things mathematically that you need for continuity, and that's the 3 things. The limits have to be the same from left and right, and the value of the function at that number has to be the same as the limit.
Okay.
Let's see, we're on 9 and 10. Do I have that somewhere?
No, it's in your picture right now. Actually, it might be in the other email that I sent you.
I've only gotten 2 from you today, and one had the top of that page, and the other had the bottom, I think.
Okay, I'm sending you a new one right now.
All right.
Okay, I just sent it.
Personally, I find these limits to be easier graphically than I do algebraically.
I agree 100%.
Yeah, when you're trying to figure them out algebraically, it's tough. When you're trying to figure them out graphically, it's a piece of cake. You just hop on board the function and follow it to the point that it's going to. So in number 8, I presume, oh no, I see. They're asking about 9 and 10. Okay. So what are the domain and range of f in 9 and 10?
Okay.
The domain is going to be the most limiting part of it, if you know what I mean.
Yes.
Okay, so for 9, what's our domain going to be? For the entire piecewise function.
Square root of 1 minus x squared. Would that be it?
What's the domain for the top part?
0 is less than or equal to x.
Yeah, x has to be between 0 and 1, right?
Yes.
And if it's not, you're going to get a negative number under the radical, and that'll violate the domain. But
Correct.
what happens when x is 1 between 1 and 2? Is that allowed?
Yes.
And what about x being equal to 2? Is that allowed?
Yes.
So what's the real domain of the 3 piecewise function?
Would it be all positive numbers?
Well, it doesn't say. No, you get the domain from this over here. In other words, the domain is 0 to 2.
Mm-hmm.
There's nothing that prevents x from being between 0 and 1. There's nothing that prevents x from being between 1 and 2. It would violate this, the top part, but when x is between 1 and 2, f of x is equal to 1. So that's fine. And when x is exactly equal to 2, f of x is equal to 2. So there's nothing that prevents x from being any number between 0 and 2. Now, you might say, well, how come x can't be minus 1? Well, because when you're talking about a piecewise function, this defines your domain. X can't be minus 1 because it's not listed here.
Okay.
Okay? Now let's figure out the range. In order to figure out the range, we have to figure out all of the values that it might be when x is between 0 and 1, also the values that it might be when x is between 1 and 2, and all of the values that it might be when x is equal to 2. So if I'm going to list the range, f of x can be equal to what when x is between 0 and 1?
F of x has to be what when x is between 0 and 1? It has to be either 0 or 1.
Well, 0 to 1. Correct?
Okay, so 0.5.
Yeah, no, it could be fractions. In other words, let's make x 1/4. Or, whatever. In other words, I can produce any number you want from 0 to 1 by specifying a certain x. In other words, if I took the square root of 1/4, I would get 1/2, right?
Yeah.
So pretty much, regardless of what I want to produce for f of x, I can come up with any number between 0 and 1, including 0 and including 1. If I want to come up with 0, then I make x equal, x can't be 1. So that is a parenthesis for that part of the range. In other words, there's no way I can make f of x equal to 0.
Okay.
X would have to be 1, right? But
Yes.
if x were 1, f of x would be 1, not 0. Well, can I make the range on the first part of the piecewise function, can I make it 1? Yes, because x can be 0. Square root of 1 is 1. So I do need a bracket on that part of the range. And then, so you know interval notation, is that correct?
Correct.
So I'm in combination with 1 in combination with 2.
Yeah.
In other words, those are the possible f of x's that you would get no matter what you plug in for the allowable domain. You can't get anything but this. You can get all numbers between 0 and 1. You can also get the number 1, and you can also get the number 2. Perhaps I don't need that second one, because that really duplicates this one, doesn't it? Yeah,
Yes.
I think I can erase the middle one. I don't need that. I just need this. So you have this in combination with that number, and that's it.
Okay.
Okay. And let's see, we got time to do 10. What's the domain on 10? And remember, you're going to get your domain just by reading the right side.
So that would be 0 is less than or equal, or less than x is less than or equal to 1.
Well, this part of the domain is 0 to 1. And even though that's a greater than sign and not a greater than or equal, the next part is x equal to 0. So that gives us our domain 0 to 1. So far we're here with the domain through the first two pieces of that piecewise function. And in the third piece, x can be less than 1 and x can be greater than 1. So what's my total domain?
Bracket 0.
Well, actually negative infinity.
Okay. Negative infinity.
Because x can be less than minus 1. Well, negative infinity counts. And I can go up to 1. And then in combination with x can be greater than 1, but it also can be equal to 1 from the first part. So that's also a bracket. So 1 to infinity.
Okay.
And what does that tell you? Looking at that bottom row, what does that tell you?
That shows
Why
that
do I have a gap here? There should not be a gap there. This one goes up to 1 and this one starts at 1. And both of them have brackets. So my real domain is negative infinity to positive infinity. Right? I mean, I don't see any value that x cannot be. X can be, except no, x can be negative 1 from the first part. And
True.
it can certainly, oh, you know what? I was misreading this. I didn't realize there were two parts to the domain on the first one. So let's see. We're going from negative 1 to 0. We're going from 0 to 1. We're going at 0. We're going less than negative 1, and we're going greater than 1. That's still the correct answer for domain. Negative infinity to infinity.
Okay.
Range. I would say that it's from minus 1 to 1 because it's equal to x whenever it's in that range, or it's equal to 1 when it's in that range. So it's definitely minus 1 to 1. That's the range because the third piece puts 0 in there. So x can only be x, f of x can only be x, which means it's going to be from -1 to 1 based on the top part, or it can be 0 or 1 based on the middle and the bottom part. That's it. So my complete range is -1 bracket, -1 to 1 bracket
Okay.
for number 10.
I appreciate it. I'll talk to you next Wednesday.
Sounds good, Taylor. Make sure you make your appointment early. I tend to get very heavily booked at this time of year.
Okay, it's because of finals.
Absolutely. I was booked solid yesterday, today, and tomorrow. So next week will
Wow.
be worse. So
Okay. Thank you. Have a good day.